My name is Wrigley and I'm working as a lead consultant for SHI, a service provider based in South Germany, dealing with AI projects, search projects and analytics projects. Encountering situations like inconsistent data, missing data or just too little available data makes any data-driven project a huge challenge. So in my session I'm going to show you how you can use AI cloud services to overcome these obstacles and make your AI project a success. I hope you enjoy it, so let's get started. Hi, and a warm welcome from Germany to my session, AI Cloud Services to your on-prem data workflows for natural language processing and content enrichment. Unfortunately, we cannot all be in Vilnius, but I hope you have a great time joining this session remotely from wherever you are. Let's talk about the agenda real quick, what we are going to cover in the next 3/4 of an hour. So we'll start with identifying what actually the problem is that we want to solve. And as we want to deal with AI, with data, with machine learning, we kind of need to cover a couple of things to get started. So first thing is we kind of need to get data to do artificial intelligence or machine learning. Next is we not only need to retrieve the data, we also need to store the data somewhere. And the interesting part always is kind of in between. So after retrieving and storing the data, we need to process the data. And this will be the next and definitely the most interesting part in this presentation. Now, we want to do machine learning or artificial intelligence. So there are a couple of challenges that, well, we need to tackle, we need to overcome. And one way of doing so is using services that cloud providers offer us. And I'm going to show you a demonstration using one service where we can add artificial intelligence in our on-premise data workflows. After that, I'm going to give you a couple of key takeaways from my perspective that hopefully help you in your professional life. So let's start with identifying what the problem is. So nowadays, everyone has a lot of data. And this is clearly not really a challenge that we need to deal with. So we have a lot of data. That's not an issue. That's just a fact. And usually we can store a lot of data because cost for storage has been decreasing for the last years and decades. So storing the data is not really an issue itself, which is rather obvious and clear, I guess. And usually nowadays we have loads of open source frameworks or commercial proprietary tools that we can use to process a lot of data. So scalable frameworks are usually also not the challenges and the obstacles that we need to deal with. So maybe we need to dive into all of these three things a little deeper to identify where the challenges actually are and how we can solve them. So first, we need data, and usually we already have a lot of data stored across various data sources and silos, and we have a couple of options in the open source market, which I'm going to focus on. And there are also a lot of commercial tools, but let's stick with, let's say, a couple of open source variants that we have available. So we have a couple of that I'm going to name here, which I like to call multi-tools because they are not really used for one use case. They are used for a broad variety of use cases, for example, log analytics, IoT use cases, and so on. And one of them that we are also going to see in the demonstration is Apache NiFi. Apache NiFi has been originally developed by the NSA, and if someone knows how to collect data, the NSA does. And it has been open sourced a couple of years ago and is now under the hood of the Apache Software Foundation being developed. We are going to get to know Apache NiFi in a couple of minutes. If you want to dive deeper into Apache NiFi, I can already recommend the next talk by Timothy Spann, who gives an introduction to the Flank stack, covering not only NiFi, but also other tools like Flink and Kafka. Other multi-tools available are StreamSets, Apache Flume, and Vector, and they are all capable of connecting different data sources, processing the data in at least simple ways, and storing the data also again in several data storage options. If we are collecting logs and metrics, I think Logstash and Beats from the company Elastic, also open source, they are the options which are most widely distributed, and they are rather easy to install, easy to configure, and they are small data shippers, which also have a configurable way of, well, configuring how you want to retrieve the data and how you want to process the data in a rather broad sense. If you do web crawling, you have either large-scale frameworks like Apache Nudge or smallish frameworks like Scrapy, which is a Python tool for, well, ingesting, let's say, small-scale web crawling projects. So getting the data, retrieving the data out of our data sources, be that databases, be that file systems, or the web, is rather a solved issue, and we have a broad variety of tools that we can use to do so. So I think we can check this off and get to the next question: how can we store the data? As I said, storage costs decreased over the last years, and we don't really have only the option to store everything on a disk. We have distributed file systems like the Hadoop distributed file systems. We have NoSQL data stores like Apache Solr, Elasticsearch, Hive, MongoDB, whatever there is, search technologies, documented-oriented, column-oriented. So there are several options here. We also have SQL data stores, of course, relational databases where we can store data. We have cloud services from Amazon, from Google, from Microsoft. They all offer kind of services to store data. And of course, you can set up your private cloud, your private data center within your own infrastructure. So again, here, several options, and I think the projects always define which are the best ones. And I don't think storing the data itself is a huge obstacle in most of the cases. So we only have one thing left, and that is processing the data. Processing the data can be done within the ingestion frameworks or ETL tools that we use. So for example, NiFi, Vector, StreamSets, and Apache Flume that I have mentioned before, they have, let's say, options of processing data, simple transformations, for example, going from XML to JSON, or splitting a log file by lines, stuff like that, which is rather basic. But when it comes to the interesting stuff, so machine learning and also artificial intelligence, we tend to turn to tools like Apache Spark, Flink, or Kafka, because they offer a broader variety of options where we can really process the data, doing or training machine learning models, applying them on newly incoming data, and so on. And this is something which we cannot just, well, let's say, skip, because this is kind of where the magic happens. And this is something where we kind of need to focus on to really choose the right options for processing our data. And if we put these things now together, we might come up with, let's say, a data processing architecture, which might look like this. So in the bottom left corner, we have data and our data sources. We need some kind of tools to integrate the data, so reading the data, retrieving the data out of our data sources, doing basic transformation stuff, and then storing the data into our storage layer in the bottom right corner. When we have, let's say, kind of stream processing scenario, while integrating the data, we kind of do this loop and maybe process the data by aggregating it, or we process the data by applying machine learning models on it, and we store the results of this process afterwards. And sometimes after we stored the data, for example, we store 30 days of log data, We want to, let's say, create knowledge out of this 30-day package of data. So we first need to store it and then process the data after these 30 days of data have been stored in our storage layer, and again store the results of this analysis back into our storage layer. Afterwards, we need, this is now the middle right corner here, the visualization layer. We need some kind of visualization on top of our storage layer to present these results in a, let's call it manager-suitable or management-suitable manner, so that what we want to get as a result out of this can be presented in a rather, well, easily understandable way. And the things that are, well, the most complicated parts here are definitely the machine learning part and the data processing part. And there are a couple of challenges, and I have identified 3 that I want to mention today that we need to tackle and to overcome to, let's say, succeed in our machine learning or AI project that we want to tackle in that case. So, challenge number 1, lack of talent. Working with data, especially with unstructured data, requires expertise. I think everyone would agree with that fact. And there are, let's say, different flavors of expertise that we kind of need to deal with data, especially with unstructured data. So we kind of need data engineers. We need to know where's the data stored, how can we access the data, how do we need to transform the data, and how do we need to store the data in our storage layer to, well, extract the value that we need. We might also need data scientists, so persons who have a very deep understanding of the data that we want to work with, because if we don't understand the data that we have, we're kind of bound to fail if we, well, don't have this knowledge of the data that we're working with. So we need an understanding of the data. When dealing with text, with unstructured data, it's also very beneficial if we have natural language processing experts, computational linguists, something like that, because we're not dealing with Booleans here, we're not dealing with numbers or enums, we're dealing with text. So we need to understand how are sentences or words composed, what are entities, what are the kinds of entities that we have in our text, to also be able to enrich this data, to extract these entities, maybe also to identify relationships between these entities, and so on and so forth. It's also helpful if we have a machine learning or artificial intelligence setting, scenario, project, use case, that we have machine learning engineers in our team, because they tend to know the math, the statistics, the machine learning algorithms, and they know which ones to apply to our data and to our business case, so we can drive or draw the value out of the data that we need. And chances are you don't have all of these in your team or in your company, so this can be a real challenge that you need to tackle and to overcome. But this is not the only challenge. There's also another challenge, which is, which I am calling lack of data. And now you might be surprised and say, wait a second, lack of data? I just said 10 minutes ago that everyone has a lot of data, and now you're saying this is a challenge. Yes, indeed. Not the data itself is the challenge, but if we want to do supervised learning, so for example, classification tasks, we need labeled data, not just any kind of data or raw data. And if we want to do maybe not classification tasks, but if we stick with the named entity recognition example that I just mentioned a couple of seconds ago, we need a training data set to train our own model. And we need all the entities that we want to identify in newly incoming messages. We need that labeled. And if we use, for example, tools like Apache OpenNLP, we need around about 15,000 annotated sentences with the also already labeled, entities for our training data set. And usually this is not the format that we have our data in, because this is something that we want to have afterwards, after our machine learning or artificial intelligence project and not beforehand. So we need labeled data, and this can be a real challenge. How can this labeled data look like? So this is a simple example that I've pinched from the Apache OpenNLP website. We have a simple sentence here. The sentence goes like this: Pierre Winken, 61 years old, will join the board as a non-executive director on November the 29th. And we have one so-called entity in here. This is a person. The person is called Pierre Winken, and with this XML notation, which is used in Apache OpenNLP, we have this entity labeled in this sentence. And now we need 15,000 of these sentences to train our machine learning model to be able to recognize entities from full text. So this is the challenge number 2 that we need to face and to tackle. Challenge number 3 might be a lack of resources. So when we have machine learning tasks that we need to do, we usually need to train models. After we train models, we need to evaluate them. After evaluating them, we kind of know how we can improve them. So we need to tune these models by hyperparameter tuning, for example. And we do this in several iterations, and this can be time consuming. So let's say we can have one model iteration per day, and we need 10 days to do so. We at least need 10 days, 10 working days, 2 weeks to have the best model that we want to have to apply to our tasks. And this can be time consuming because maybe it's not only 10 iterations, maybe we can't even do 1 iteration per day. So this might be a real challenge to face. We are rather slow in putting our machine learning models into production. It's also the case that sometimes training phases can require additional hardware because while training our machine learning models, we need more hardware. After the training is done, we need less hardware. So we kind of have resources which are not, well, used in an optimal way. And this is also known as a challenge that we might face. I think there are more challenges than these 3, but these are the 3 that I've picked for my presentation today. And now we need to find a way how we can overcome these challenges and tackle these challenges so they are no challenges any longer. And now, well, let's say we have an idea and we don't do everything by ourselves. We just move everything which is a challenge for us to the cloud. And by moving to the cloud and remembering the blueprint, the architecture blueprint I showed you 5 slides ago, we can now adjust this and say, okay, let's say we want to do machine learning. We want to extract and identify entities from news items which we retrieve out of the internet. And by doing so, we can use an API, the GDELT API, which is freely available to grab some news. And we will do so by using Apache NiFi in the demo that I'm going to show you in a couple of seconds. And we're going to integrate this data in kind of a streaming manner. And we pinch these news items. We throw these news items against an AI service. In that case, this will be the natural language processing API in the Google Cloud Platform. And the Google Cloud Platform, sorry about that, identifies all the entities which are in our text, so persons, locations, organizations. It enriches our data, puts it back to our NiFi data workflow, and we post-process the data and store it then in an Elasticsearch index. And afterwards, we put Kibana as a visualization layer onto Elasticsearch, and we are going to have a smallish news dashboard, which is able to, let's say, not only show us how many entities have been retrieved, identified, and extracted, but also what kind of relationship they might be to each other. And this is what I've just mentioned. So we have one data source, the GDELT API, which is a news monitoring project. We'll request the latest news by calling this API. We'll extract these news items and transform them so we can extract the content from them and send that to the natural language API that Google provides us with. We'll extract entities, persons, organizations, locations. We'll let the API also categorize this news item and extract the language out of it by identifying the language from the content. And afterwards, we'll send our results to Elasticsearch, store everything there, and visualize what we have stored in Elasticsearch. So let me show you what I have put together in a couple of hours. So this is not error prone, I must say. So it is rather likely that we might see one or the other error in this workflow, as this is now really a real-time use case that we're now working with. So I hope you excuse me for that. And I won't really, well, let's say, push my internet connection too much. So I'll only retrieve once the latest news from the GDELT API and not process that all the time now. And now we'll move through this demo setting step by step and see how this data can be processed by NiFi, how the data or how the content can be enriched after we've called the Google Cloud Platform API, and afterwards we're going to visualize that. So now we have requested by a very simple API call the latest news of this GDELT API. So we just retrieved the last update. We have a couple of links in here, and we're going to extract these links now. And afterwards, we are going to invoke or request the data from these links that we have extracted. I'm going to run every processor, which are the building blocks of our data flow here, only once to not, let's say, push my internet connection too hard. We get everything in a zip archive now. And in this zip archive, we have basically a CSV file. And in this CSV file, which we are splitting here, we now should get a couple of thousand, 1,680 actual news items in that case. So now we have, going to show you that real quick maybe, 1,680 of these news items, and if we pick one and view this, we have a link to the actual news item here, and we see, okay, this is now about COVID-19. So basically the reason why we're doing this remotely, and we're going to request this website in the next step. Oh, sorry, we are extracting the link in this step, and in that step we are requesting the HTML page itself. After we've reached the HTML, we want to strip the HTML, so we only have raw text that we can work with. And up to now, we have worked with only, let's say, NiFi internal processors here, so nothing has been really implemented in that case. We are only dragging and dropping processors in here, connecting them by relationships. And this is now a custom processor that I have downloaded from GitHub. This is by Timothy Span, so who is doing the introduction to the Flank stack, which is right after my talk. So if you want to know more about NiFi, especially how NiFi, Flink, and Kafka work together, I recommend that you check that out because he's implementing his own processors. He knows what he's talking about. And this processor now is able to extract all the text out of our HTML that we have requested. And now we can have a look at this piece of data once more. And we see, hopefully, that we now have everything extracted. We also see, yes, this is a home page, and this is basically not really very nice content in that case, but there should be, let's say, some entities that we can extract out of this news item, and we'll see how well that goes when we proceed with our data flow here. So after we have extracted the content, we'll put this content from the body to an attribute of a flow file currently. We'll generate a piece of JSON which we can send to the Google Cloud platform afterwards. So this is only a templating step. We are replacing the placeholders in this JSON by the content that we have extracted from this news item. And after this step here, all have been successful so far. So now this is going to be interesting. Now we have JSON content, which, excuse me, looks like this. So now we have a document of type plain text, and here is the content that we have extracted, moving all the way down. And here we say what we want to have enriched from the Google Cloud Platform API. We want syntax analysis, we want the entities, we want the sentiment, we want the entity sentiment to be detected, and we want classification to be done. And now let's see if this is a valid JSON, and we send that to the Google Cloud API, and we have a failure over here. Bad luck. So I'm sorry about that. We'll just pinch the next news item and hope that this will work. Okay, so this one worked. At least 1 out of 2 for the demonstration. And now we can have a look at what the Google API can tell us about this new news item that we are now watching. So this is maybe, or most likely, something about PS5, Xbox Series, so the new gaming revolution, maybe. We see a couple of sentences here. If I close that, we see all the tokens that have been detected with part of speech tagging, so syntax information in here. And here we have entities. So we have other entities, we have organizations, and proper nouns. We have an event in that case, and so on. And we'll see the persons, organizations, and locations that have been extracted out of this in a minute, because this is what the next steps do. So in that case, we are calling a script. This is the only custom code, in fact, that I have put into this, let's say, data flow. It's only, let's say, 30 lines. I can show you that real quick. So this is nothing else than parsing the output of the API and putting everything in several variables and storing these variables to this flow file object that we pass through our data flow. And after we have that, we construct a piece of JSON that we can send to Elasticsearch in this last step. So we basically have an ETL workflow here. So we extracted data from a data source, which is an API. We transformed it. We called an external service, a cloud service, and now we are loading everything in Elasticsearch. So now I think this is still running, and I think we are retrieving like 1 news item per minute in this step over here. So we'll let NiFi do the job from here and process, let's say, one news item per minute. And now we see what has been extracted. So we have this news counter. 2 have been processed so far in the last 15 minutes. We see the categories that have been detected. The first one that we had a closer look at least a smallish closer look at, was about games, computer and video games. I think we all would agree because the PS5 and the new Xbox console were mentioned. Here we have locations that have been detected. Language is English for both of the news items. And here we see organizations and we see persons which have been detected. We also see that, well, this might not be the best entity extraction that we might come up with, because we have a person called Hitman in here. I think everyone who's into the gaming scene might know that Hitman is a rather famous video game. And I probably wouldn't call the Hitman a real person that we want to extract here, but that basically probably that is up to you and your use case and business case, what valid entities are in your content and what not. So now the next one is already arriving, and we are getting more and more of these entities. And if I now extend this to not only the last 15 minutes, but maybe, let's say, 7 days, because I played around with that at least for a couple of entities within the last week. We now have 109. And if we now have a look at the persons down here, we see, for example, Joe Biden as a person. We see Trump as a person, and we could now say, okay, let's maybe go for Trump and filter our dashboard for him. And now we see in here which other persons Trump is basically related to, and we see which organizations Donald Trump is related to and which locations he is related to. So now we can kind of drill into our data and see what relations we have with rather simple steps that we did. So we now have a very small and rather easy workflow running, and this workflow really is also capable with enriching the data that we are passing in. And this enriched data is now, well, shown in this very simple dashboard that we are seeing here. And this is basically what I wanted to demonstrate, how easy it is to use cloud services in an AI project, at least when you want to start an AI project. And I am going to stop everything here now and return to the slides to, well, kind of wrap things up. And let's say we want to have a basic understanding of, well, okay, we've seen that cloud services work. They can be rather easily integrated. But when should I really use cloud services? So we have kind of this pros and cons here. Cloud services use pre-trained models when we have this kind of machine learning setting. And that way we accelerate time to market. So we are faster in kind of deploying our applications, or at least finding out whether this application that we want to build really has a business value or not. We can compensate lack of talent, because I don't really need to know what the data actually is, for example, that we're dealing with here. I know it's text, and I know that the Google Cloud Platform Natural Language API can deal with text. So I just take the text and throw it into this API and take the response and work with it. So I can compensate for lack of talent. I don't need to build a highly sophisticated team for weeks or months. I can start real quick. I might have less operational costs, because I don't need like 10 servers to build and train my models on, to evaluate everything, retrain everything, and so on. I just use an API and pay for the usage of the API, and not really for any operational costs like servers that I need in my data center and so on. I need less know-how because I only need to know how does this API actually work? What does it need and what does it give me? And afterwards, I can actually start right away. The APIs, or cloud services, they integrate rather well with other tools. We've seen it just takes a JSON in and it gives you a JSON back. So integration is not really much more than two processors basically in Apache NiFi, and it's rather similar when working with other open source tools. You pay as you go, so when you use it rather frequently, you pay more. If you don't use it, you don't pay anything. If you have a high load on one day, you have a higher bill on one day. If you have a low load on the other day, you have a low bill on the other day. Might be an advantage, might also be a disadvantage, to be honest here. And I think what the main benefit is, it enables you to rapidly build a prototype. So if you have an idea, and if you want to start real quick to see whether this idea makes sense, whether this idea has a business impact or a business value for you or your company, it is rather easy to use a cloud service, and it is rather difficult to get the data, train the model, have the right persons to train the model, and so on. So this enables you to really quickly find out whether this idea you have makes sense or not. But cloud services don't only come with advantages, there are also a couple of disadvantages. So we have a black box here. We have no control. So we can't say, well, maybe I need to retrain a model, or maybe I need to emphasize on one part like persons, but not on the other part like organizations. So we don't really have any control in here, which is, in my opinion, a rather major downside, in fact. The models from cloud services, they are often not really domain specific, they are general models. And if we need to, let's say, put domain specific know-how into our data, then these general AI cloud services don't really help us. So if, for example, we want to detect entities, but we don't want to detect entities like the usual ones, persons, locations, organizations, but we want to detect, I don't know, colors or brands or special numbers or vaccination abbreviations or whatever there is, we need to train our own model. And this is nothing that cloud services really provide us with out of the box, at least. And I already mentioned high usage might mean high cost. So your bills might be rather high if you use these services extensively. So what I have mentioned as an advantage might also turn into a disadvantage, to be honest here. And we've seen that a couple of these entities, they were not really high quality entities. For example, people is not really a person entity, but well, the service thinks it is. And so we kind of always need some tooling around these services. So we might need whitelists, blacklists, we might need sanity checks, and so on. So there ain't no such thing as a free lunch, which also applies in this case here. And I guess we would need some tooling around these cloud services in any case. What are the key takeaways for you now? To wrap things up, a lot of technologies, frameworks, and services are out there for, well, ingesting data, processing data, storing data. And some parts of data-driven projects are easier than other ones, especially retrieving the data, storing the data. Processing the data is sometimes the tricky part. And they are starting with a cloud service might make sense to accelerate time to market and to do fast experiments and see whether this idea you have works or doesn't work. You don't need a huge team of experts, and that definitely is a key benefit to really start quickly. But if you have a more sophisticated use case or business case, you probably need to build your own to gain really full control and also to, well, be able to put your domain knowledge into your project. So this is really necessary in most of the cases, unfortunately. The resources that I've used and that we've already seen, the GDELT project, Apache NiFi, the Google Cloud Natural Language API are listed here. OpenNLP is a great tool if you want to train your own model. If you want to use pre-trained models in your own systems, I recommend you have a look at Spacey or Hello OpenNLP, which is a service, pre-built service for you, freely available in open source, which uses Spacey already. So you could use that in your on-prem data flows altogether. And with that, I am thanking you very much for your attention. If you wish, you can connect with me on social media. Thank you for your attention. I hope you enjoy the rest of the conference, and I hope we can all see each other next year when we are back in Vilnius. And now I am able to pick questions if there are any. And I'm having a look at Slido right at the moment, and I am not seeing any questions right now. I hope I am in the right session here, but it looks like it. So if you have any questions, please feel free to ask them now. I will join the Ask Me Anything corner or session in the Zoom room afterwards. So if you have a question and don't want to ask it right now in the Slido application, I'm happy to take that in the Zoom room instead. But for now, you still have the option of asking your question via Slido. So anything coming up? It doesn't really look like it. So I suggest anyone that has a question may join the Zoom room in a couple of minutes, and I would leave it with here. Thank you again for your attention. Thanks for, one question is showing up. Okay, so I'm taking that one as we still have 3 minutes left of time. What industries is AI most relevant now? Well, I think this is an excellent question, and we see AI being applied in nearly all industries nowadays, but I think probably the ones who have been applying AI as a first industry and are also applying it rather heavily right now is in e-commerce. So if you think of, for example, recommendations, that's a really basic example. E-commerce have been applying recommendation algorithms for decades now, more or less. They are applying AI in segmenting their customers. They are applying AI within their search. So when you type something in, getting the right recommendations and suggestions. So I would say e-commerce is probably always one of the first industries to pick things up. We also see a lot going on, of course, with everything coming into IoT. So the Internet of Things, there's a lot of AI stuff going on right now. Healthcare, of course, nowadays is really a huge driver for AI. So probably I would say these three are the ones which we see most, at least from our perspective. But AI is, I would say, a key driver for almost any businesses. And the ones who don't apply AI or machine learning techniques or technologies, they will probably be the ones who will not, survive, maybe, at least. But we'll see where our track leaves us, or where the track leads us, basically. So thank you for that question. And I think that's it. No other questions have been showing up in the last couple of minutes. So again, thank you. Hopefully we'll see each other next year. And that's it for this session. Thanks.